The carpenter's rule is to measure twice and then cut once. So in this video, let's spend a few moments with a plan regarding implementing high availability, and then in the subsequent videos, we'll follow that plan. Now, as far as our plan goes, to have the best chance of success, we need to get these guys, Firewall 1 and Firewall 2, as close to twinhood as we can. Now, I think it's funny when I say it, but these guys need to be virtually identical. So that would include the model. So if we have two hardware appliances that we're using, we'd want to use the same exact model. We'd want to make sure they're running the same exact version of software. So if we're going to update these before we do the high availability pair, we'd want to update the antivirus and then also update the operating system on the firewalls, make sure they're the exact same before we attempt to go ahead and do the high availability. So model, version, number of interfaces. Also, where those interfaces are connected. So over here on 1/1, these need to be in the same VLAN. 1/3 on both of them needs to be in the same VLAN. In my lab environment, this is the going to the inside corporate network on the 10.10 network. Now here it's going out to my little pseudo lab internet. That's at 23.1.2. That's the address space out there. I also have DMZs on each of these, and they would also need to go into the corresponding same subnet, same VLAN. And for these connections right here, it'd be best to use a cable and just do a crossover cable to connect them directly together and not have them in a switch and have them in the same VLAN on the switch. And the reason is if the switch failed, if we had a switch right here and they were both connected to the switch, they would both think they lost that interface. They'd both think they can't see each other. And then hopefully the one that's active could stay active and it wouldn't trigger a failover event. And we wouldn't have a split brain condition where both of them are going active because they think the other one's dead. So having a direct cable and not injecting another piece of hardware between them is ideal when possible. I also realize there may be some exceptions where we can't have a direct connection between them, but whenever possible, that's what we should do. Another element that needs to be the same on both is licensing. So if we have a threat prevention license on Firewall 1, we need to have a threat prevention license on Firewall 2. So here's what I have set up in my lab environment. I have all the interfaces that are supposed to be in the same VLAN as each other. So 1.1 on both are in the same VLAN, 1.3 are in the same VLAN as each other. And I've also logically got the HA1 and HA2 connections in place. Now, as far as the interfaces there, because these are virtual machines, I'm using 1/4, or we're going to use 1/4 for the HA1 link on both sides. And for the HA2 link, we'll use interface 1/5. And as part of that, we'll have to go into those interfaces, which are generally data plane interfaces, and we'll say, hey, guess what? You get to be HA interfaces today. And so we'll specify the type as HA. And then when we configure the high availability, those interfaces will be available for that purpose. Also for priorities, let's do this. Let's give Firewall 1 a priority of 75, which is better than a higher number priority of 100. And so let's also enable preempt on each of them. So that way, when a firewall comes up, if it sees that its priority is better, in the case of 75 versus 100, it's going to go ahead and take over the active role for the HA pair. So with that plan in place, what you and I get to do in the next video is make it happen. So I'll walk you through the steps of implementing active-passive HA on 2 Palo Alto firewalls in the next video. I'll see you there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.